Group 6 of the periodic table consists of 4 transition metals: chromium, molybdenum, tungsten, and seaborgium. First in the group is chromium, discovered in 1797. As you can see and probably already knew, chromium is a very shiny metal. It's the 21st most abundant element in Earth's crust. The most common ores are chromium spinelides and chromite. Commercially, the 0, tri, and hexavalent oxidation states are most important, but other oxidation states are possible for chromium. It's often used as a protective coating for other metals and as an ingredient for alloys, specifically stainless steels. Some examples of chromium binary compounds are chromium 3 oxide and chromium 3 chloride. The oxide, pictured to the top right, is a bright green powder used as a pigment. The chloride forms a beautiful violet solid when unhydrated, but in the hydrated form, it's comparable to the oxide's green hue, as shown in the photos below that of the chromium 3 oxide. Chromyl chloride is a complex chromium compound that very closely resembles elemental bromine. Iron 2 chromite is a crystalline mineral made up of iron and chromium oxides. Finally, chromocene consists of a chromium atom sandwiched between 2 benzene rings. Iron 2 chromite and chromocene are both coordination complexes, but the latter is also an organometallic compound. Next is molybdenum, found in 1778. It's a silvery white metal that can be found mostly in molybdenite ores, but is also found in wolfenite and powellite ores. Molybdenum is mostly used in alloys because of its properties. It's very resistant to corrosion and has the 3rd highest melting point of all pure elements. Molybdenum hexafluoride is a binary compound with few uses. Mesitylene molybdenum tricarbonyl, the top molecule pictured on the right, is a coordinated organometallic compound in the form of pale yellow crystals that can be used as a catalyst. To finish molybdenum compounds, trans bis dinitrogen bis 1,2 bis diphenylphosphinoethane molybdenum 0, which is pictured below the mesitylene molybdenum complex, is a good model for biological nitrogen fixation. Tungsten is most commonly found in scheelite and wolframite ores, and it has many uses in electrodes, heating elements, and heavy metal alloys. Tungsten carbide is the hardest metal used in jewelry, favored for its immense resistance to scratches. Ammonium paratungstate, pictured on the top to the right, is regarded as the most important raw material for all other tungsten products, according to Ullmann's Encyclopedia of Industrial Chemistry. 2 cyclopentadienyl tungsten tricarbonyl complexes can form a dimer, seen below the ammonium paratungstate complex to the right. The solid is a dark red crystalline form with few to no practical uses, although it is the subject of research. I personally love tungsten, so it had to be a chemical highlight. Tungsten is the strongest out of any natural metal with a tensile strength of 142,000 pounds per square inch. However, it's still pretty brittle. I used to drop my tungsten carbide ring from about 4 or 5 feet above a tiled floor because it was fun to watch it bounce, and one day I dropped it and a rather large chunk broke off. I was naive back then, and I assumed that strong and brittle could never coincide. Group 6 ends with seaborgium, a synthetic element which can never be found in nature. Every seaborgium isotope is radioactive, with the most stable isotopes being seaborgium-271 with a half-life of 2.4 minutes and seaborgium-269 with a half-life of 14 minutes. Seaborgium currently has no practical uses. Seaborgium has an interesting track record, so it deserves to be highlighted. In 1974, a team in Russia claimed they produced element 106. That same year, in Berkeley, California, Albert Ghiorso and his team produced the element with a different method. The researchers in Berkeley proposed that element 106 was named after Glenn T. Seaborg, but the IUPAC had a rule that elements could not be named after living people. The American Chemical Society disputed the ruling since Einsteinium was named while Einstein was still alive. There are a few examples of seaborgium compounds listed below, but unfortunately I wasn't able to find any information about any of them. Lastly, through the experimentation and research that has been conducted on seaborgium, it was found to have chemical properties similar to those of tungsten and molybdenum.